Okay, lesson 4, simplifying square root. This we've done a bunch of times because we were doing the Pythagorean theorem. And from the last lesson, you know how to estimate them. So if we had, for example, square root of 50, well, it's not perfect square, but you can recognize that it has a perfect square as one of its factors. So this 25, just the 25 is a 5. Radical 25 is 5. And this part has to stay radical 2. So you write the whole number first, and then you write the square root after it. So this is the answer to radical 50. You can simplify it. Radical 28 is the next one. Well, this is 4 times 7. So this square root of 4 is 2. And square root of 7 has to stay as such. So this is the answer for this one. Radical 18 is radical 9 times radical 2. So this is 3 radical 2 is radical 18. Now, this makes sense because if you, to go back to this part, you can square, if you square this, you should get 18. So what is, the terms inside here are 3, so this is 3 squared times radical 2 squared. Why is that true? Because we learned early in 8th grade that if you had xy to the second power, that's the same as x to the second y to the second. The two can distribute to each factor inside. Okay, so that's what we did here. The 2 can distribute to each of these factors. So what is 3 squared? Well, that's 9. What is the square root of 2 squared? That's 2. Because the 2 as the exponent cancels this square root sign, and you have 2. So 9 times 2 is 18. So if you have a square root symbol and you have a number inside, and then you square this, well, that's just 5. Because the square root of 5 is 2 point something, and that times itself makes 5. That's important to keep in mind. Okay. Let's try one that's a little bit harder. Now, on this page, number 5 is radical 108. Okay. Now let's say I can't recognize a perfect square right away, but I know it's even, so I can break it into 2 times what? 2 into 108 is 54. Okay. Now what? Well, now I can say radical 2, and this I can break into 2 times 27. And this I can further break down into radical 2, radical 2. This here is the same as 3 times 9. 3 times 9. Now what? Well, radical 2 times radical 2 is 2 whole. This radical 3, I can't simplify it. Radical 9, the square root of 9, is just 3. So this part is 3. So this part could not be simplified. So I have radical 2, no, I have 2 whole times radical 3 times 3 whole. Well, what is that? These two can combine because they're both whole numbers just sitting there. They're factors. 2 times 3 is 6. This is irrational. I cannot simplify it. 6 radical 3 is the same as radical 108. If I had recognized right away that 36 times 3 makes 108, well, then I could have jumped down to this step immediately. But do you have to? No, I didn't realize right away that 36 perfect square was a factor. So if you factor whatever the number is in there, you'll be able to simplify and recognize any square factors that are factors of your number. Okay. Let's do another one. Radical 250. Well, I know that's 25 times 10, right? And I know this right here is 5. And radical 10 just has to stay because it doesn't have a perfect square factor. It's not a prime number. 2 times 5 are factors of 10, but I can't break them out because neither of them is a perfect square. How do I, if I square this thing right here, 5 radical 10, if I square it, I should get back to 250. Well, 5 squared is 25, and what is radical 10 squared? Well, this cancels this, and I have 10. 25 times 10 is 250. Okay. Have a good day, and comment with any questions. This is a short lesson, but it's very interesting how to break down the radicals.